2.4 motion in two dimensions. We've already talked about force and acceleration being vectors and mass being a scalar, so we're going to be applying that to Newton's second law of motion, F equals ma. So in example 2.4.1, we are given a set of forces, all given in vector format, so they've all got the IJ notation, and they act on a particle which is in equilibrium. So we know that when we're in equilibrium, that means that acceleration is equal to 0. We've also had the definition that the resultant force is 0. And because in F equals ma, so because this is the resultant force, then both of those definitions would work in this equation. So we are summing the vector forces together. So I've got 2i plus 3j plus 4i minus j minus 3i plus 2j plus ai plus bj has got to equal the 0 vector. So we have looked at an example very similar to this before, so I'm just finding the resultant force when it's in vector form. The directions are already taken care of, so I can just add them together. This is just adding like terms, so I've got 2i plus 4i minus 3i, so that's 3i altogether. 2 add 4 is 6, minus 3 is 3, and then I've got a here. So we've got 3 plus a when we collect the I terms together, and then j, we've got 3 minus 1, which is 2, add 2, which is 4, add b. Therefore, a is equal to minus 3, b is equal to minus 4. Now you might prefer to do this using column vectors. It does save a little bit on the working out. So if you wanted to set it up in column vector format, so this is one that you will have seen at GCSE, you can write your vectors in this format. So it's still the same numbers. I is represented on the top of the vector and j is represented on the bottom. I quite like doing it this way just because each line then becomes an equation. So when you're looking at this, so you can kind of just focus on the 2 plus 4 minus 3 plus a equals 0, and then 3 minus 1 plus 2 plus b equals 0. So it does make it a little bit easier just to see what's happening. Therefore, feel free, if you prefer, to do your working out in vector format. It would lead to the same conclusion that a is minus 3 and b equals minus 4. Looking at example 2.4.2, so a particle P of mass 2 kilograms is moving under the action of a constant force F. F is given in bold here, so when we're doing vectors, when we're writing, you'll have noticed I've been underlining the vector components in example 2.4.1, but in the question it's given in bold. So when you're writing a vector, you would underline it because you can't write in bold, but a question would have it in bold. So we know F is a vector just because they've used bold font. When t equals 0, p has velocity 3i plus 2j, and at time t equals 4, p has velocity 15i minus 4j, find the acceleration. So we've been asked to find the acceleration, and we notice that force hasn't been given. So I can't use F equals ma. I'm looking at what I have got, and I've been given velocities and times, so that should make you think of your SUVAT equations. We have mentioned thinking like that before, so I'm looking at part A. I'm going to do this in vector format, and I'm going to go for column vectors just because I think it's a neater method. So my initial velocity, so u, is when t equals 0, so I get 3, 2 for u. V is 15 minus 4. I've been asked to find acceleration, and the time is 4 seconds. That's the time when we've got that velocity. So using v equals u plus at. T is the only scalar in that equation, so we've got 15 minus 4 is equal to 3, 2 plus 4a. So solving each of those mini equations, so subtracting the vector u off gives me 12 minus 6. So I end up with A is equal to, I'm going to go back into vector notation when I am writing down my final answer, just because the original question was given in IJ notation, sorry, not vector notation, IJ notation, because that was the original question. Part B, so find the magnitude of F. So part B, we've got F is equal to mass times acceleration. We don't know what F is. The mass is given in the question to be 2, it's a scalar, and the acceleration is 3 minus 3 over 2. So my force in vector format is 6 minus 3, but I am asked to find the magnitude of the force. So that means that I have to find the size, and we do that by using Pythagoras' theorem. So if we remember, it means that we're going 6 across, and I suppose technically we're going 3 down. But that's in terms of finding the size of that force, it doesn't matter, we've just got this. Set of results to work with. So that is equal to root 45, which is 6.7 newtons to 2 significant figures. Okay, it's good practice, especially in mechanics, to get into the habit of giving your answer in exact format. By exact format we mean surds or fractions, and then giving your answer to 2 significant figures following that. So that is a good practice to get into. Looking at part C, so I'll just create some space here. So we're looking at part C. Find the velocity at time t equals 6. So when I'm doing a question that involves vectors, I should be questioning at all points, is my answer expected to be in vector format, or am I looking for a size? If I was looking for a size here, so if I was looking for the magnitude of velocity, the question would say find the speed of p at t equals 6. Because it says velocity, I know that I can give my answer in vector format. So u, it's the same question, so u is 3,2. V is what I'm finding. The acceleration needs to be in vector form as well, so that's 3 minus 3 over 2, and then the time is 6. So V equals u plus at. V is what we're looking for. U is 3,2. 3 minus 3 over 2 for A, and then I want to times that by 6. When you times by a scalar, so we'll just get 18 for the I component, and then I'm adding 3 to it. And remember, I'm going to go into IJ notation here because that was how the question was set up. So 3 times 6 is 18, add 3. This 6 acts on this minus 3 over 2 here as well, so I get minus 9, so it's 2 minus 9, which is minus 7j. And that is the velocity. As I mentioned, if you were asked for speed, you would do exactly the same working out that I've just done, but then you would have to apply Pythagoras' theorem to that vector 24i minus 7j. So do 24 squared plus 7 squared, which will give me a speed of 25. We weren't asked for that in this question, but that's just to point out if you were asked for it, that's what it would look like. You could do part B in a slightly different order if you wanted to. So one way that you could do it would be to find the magnitude of acceleration. So if we wanted to find the magnitude of the acceleration, so this is part B, looking at it a slightly different order. So the magnitude of acceleration, when we calculate that, we get root 45 over 2. If it's an intermediate calculation, I'm not going to give it as a decimal because I haven't been asked for that. I'm just working it out so that I can use it in F equals ma. This time I'm not working in vectors because I know I'm looking for the magnitude of the force, so I would be using the acceleration or the magnitude of the acceleration, which leads to F equals root 45, which is the same as what we got the first time round. So it doesn't matter if you chose to do it that way, that's fine. Notice part A, it says the acceleration of P in terms of I and J, therefore I left it in vector form in order to answer that question.